Hi everyone, this is Arfeen, and today we are going to calculate value at risk. So let's start. First, we are going to import libraries. So import pandas as PD. So instead of importing in this way, what I'm going to do is I'm going to import all the libraries in a single line of code. So import pandas as PD, numpy as np, pandas underscore data reader as web, from scipy import stats. Also we need to import a library for graphs. So matplotlib.pyplot as plt. Let's run this. So in the meanwhile, let's write a code for data. So data is equal to web dot data frame. We need a stock name. Data source. Yahoo. We need start date. One 2020. We need end date, which is 12/31st 2020. Okay, I have done one mistake here. So I put everything in the list. So it should be like this. And then we need adjusted closing price. Okay, let's run this. Okay. Oh, it's supposed to be data reader. Sorry. Okay, so it's downloading. Once it will download, so we will check the head of the data, the top 5 rows basically. Okay, so our data is downloaded. Let's check the head of the data. Okay, so we are going to calculate return. So what I will do, return is equal to, so here we are going to calculate log return. So for that, we have a code np.log data apple divided by data apple dot shift -1. So what this line of code will do actually, it will calculate a daily return. So today's price divided by yesterday price, which is basically -1. So let's run this. Let's again check the data. Okay, so we have daily return of Apple. So we need to calculate value at risk. So for value at risk, we need volatility, we need confidence interval, and we need time. So this is the formula of basically, actually it should be square square root of time. So this is the formula of value at risk. We need to calculate volatility. So for vol, what I'm going to do is I'm going to calculate data return dot std. It will be our daily volatility. Let me add some line of codes. So let's check the vol. So it's 2.94%. Okay. And we have confidence interval. So let's say confidence interval is equal to stats dot norm dot ppf 0.99. So what I'm doing here, I'm taking 99% confidence interval. So what would be the value of 99% confidence interval? Let's check. 2.326. Okay. And time, we can put it in the formula directly. So let's calculate VAR. So VAR is equal to confidence interval, which is 99%, multiply by daily volatility into NP dot square root QRT of, let's say, 1 day VAR. So let's run this. Okay, so we can also multiply it with 100, so it will look good. Okay, so this is our VAR, a daily VAR at 99% confidence interval. We can increase number of days here. Let's say 10-day VAR. See, okay, 21.63. So now I'm going to calculate value at risk by using a user defined input, and it will be like, so for example, we have CI, which is confidence interval. So I'm going to ask from user to input the data at any time whenever they are going to run the code. So enter the confidence interval. I'm also going to calculate or ask from the user to input the time. So input here, I'm doing some mistake, which I will show you in a while, because if I will right away put the right code, so in future, if you are going to use input function, so you could do the same mistake, which I'm going to do now. So enter the time horizon. Okay, let's run this. So my confidence interval is 99 and my time horizon is, let's say, 1 day. Okay, let me do it in this way so it will look more presentable. 99 and 1 day. Okay, so I'm going to use the same line of code where I'm going to put value at risk is equal to, so what I'm going to do here is I'm going to calculate CI is equal to stats dot norm dot ppf and CI. Okay, I'm also leaving one more thing here, and then time is equal to nb dot sqrt of time, which is basically the input here. And then we will have a value at risk formula. So we already have volatility here. We can calculate it here. We can calculate it in another line. That's perfectly fine. There is no issues. So since everything is here, I'm going to copy this and paste it here so it will look more decent and good. Okay, so what we have here, let's say vol into confidence interval into time multiply by 100. So let's run this. Now, mistake number one. Perfect. So if you can see here, it's 99 and we should give or provide a confidence level or probability in the range of 0 to 1. So what I'm going to do here is I'm going to divide it by 100. Let's run this. 99 1. Now there is one more mistake. What I'm going to do here is, because if I'm going to input anything, it will take it as a string. So I'm going to assign this number which I am putting as an input as a float. So let's run this. 99 1. Okay. Similarly, here I'm going to put int. So I think there must be one question coming in your mind, that why I'm putting float here and why I'm putting integer here. So confidence interval could be 97.5, 95.5, 99.9, whereas time cannot be in decimal. So that's why I'm putting it as an integer. So it will be 1, 2, 3, and so on. So let's run this. 99, 1. Oops, I didn't print value at risk. Perfect. So let's print it in a presentable form. So print the value at risk of Apple is curly braces. Okay. Dot format value at risk. Let's run this again. 99 1. Okay, so let's put it in two decimal place. So it will be 0.2 floating, and let's put it in percentage. So 99 1. So the value at risk of Apple is 6.85%. We can also, it doesn't look good, so I'm going to say confidence interval, time horizon, and print a line and then 99 1. Okay, so the confidence interval is 99, time horizon 1 day, and the value at risk of Apple is 6.85. Let me show you one more thing. So 97.5, 10 days. Perfect. So this is working properly. Since we are putting or assigning a number in floating, so it will give us the right result what we are expecting. Okay, there are some small things which I wanted to share with you. So let's count the data set. So I'm going to see the data information here, and the data information we have here is Apple stock price was 253 while return is 252. While we are calculating, or we usually calculate value at risk for 250 working days. So for in this case, what we need to change, we need to only change the volatility. So what we can do is we can calculate vol underscore 250 days is equal to data return of, so we have 250 52 days. So what I'm going to do, I'm going to say start from 2 and end up to the last number dot std. Let's run this and let's check the vol. 2.954%, while the volatility here was 2.94. Okay, so we need to see the exact number of days that are we taking the right numbers or not. So I'm going to copy this line of code and paste it here and say count. So we have 250 number of data point or 250 data point. So, okay, this is one part. So in order to calculate volatility of 250 working days, all I need to do is I need to put 2 here. So what this line of code will do, it will calculate the volatility of only 250 working days. So let's run this and 99, 1, 6.87%. So we can also do it in terms of amount. So let's say we have an amount of, let's say, uh, the value at risk of Apple is, again, I'm going to do the same thing, 0.2 floating and USD dot format value at risk multiply by, let's say we have invested 100,000. So let's run this. 99, 1. So this is basically the amount value at risk of Apple is 6.87 percentage in terms of percentage, and in terms of amount, the value at risk of Apple is 68720, which is 68,000 prox. So that's all for today. If you have any comments, if you have any query, just feel free to ask. If you want me to calculate any of the response or any develop any model, just feel free to put it in the comment section below, and I will really try my best to do it ASAP. I hope it's clear and it's useful for you. If you like this video, please subscribe my channel and hit the like button and a bell icon. Thank you so much.